before you continue with this, just for my own ignorance, how do you create a molecule?
Okay, well, the molecular structure of the spike protein of coronavirus was published in Science back in February, I think. So really, I spent 3 days reading scientific papers, and it's like when a computer is doing stuff in the background and you're reading and you're trying to integrate a lot of information. Really, it was 3 days. It was crazy. I was just reading and reading and thinking. It was a super creative 3 days for me. And I talked my husband, who is not a virologist, into reading virology papers so that I would have somebody to talk to, because it's just the two of us in this apartment and we can't go out. So he was a good sport and he read papers with me. And when I decided on what I wanted to do and what I wanted to build, you basically could go into the scientific literature and you can pull out the information you need. And there was sequence data, there was structured data, and I took pieces of things that I wanted and I built it. And then I sent it to my colleague in New York and said, is this viable? Do you think this is structurally viable? And she's a structural biologist. So she refined it a little, she tweaked it a little, and then she goes, I think this is a go. So once we had the structure, then it was, this is something that's brand new, a brand new molecule. Is it really going to be functional? And is the immune system going to recognize it? And that was when we turfed it to the colleague in Seattle, and she gave me the results. I was super excited.
So now when it goes to testing with monkeys, and let's say it's successful, what is the possibility, the percentage of probabilities that it will work with people from monkeys?
Oh, yeah. So again, we'll test in monkeys using the DNA version and the protein version.
Correct.
I would like to see both, if it turns out. So based on the results in the monkeys, we'll see which one is giving the strongest results. If it turns out that the strongest one is coming from the DNA and protein, and if the protein is the second strongest, I would move both of them into clinical trials, because protein vaccines translate well from monkeys to people.
Okay.
DNA vaccines less so, but you could move both into a phase 1 trial and see how they work.
And how long will it take the trial in people before it is viable for commercialization?
So that's, again, dependence, right? Everybody's asking me this question, and if everybody does their job and works hard and we raise the money for making the protein and there are no stumbling blocks, it can go quickly. And that requires also a partnership with a pharmaceutical company. But pharmaceutical companies right now, the vaccine companies, they are developing their own vaccines and they're less interested in doing something with somebody else. If everybody helps with this, we could go quickly. If everybody's stumbling and hawing, and then it's going to take a long time. So it depends. In terms of the science, we could make it move really fast. My colleagues are great. We work super hard. The 3 days that I worked here, I think my husband cooked for the 3 days. I just didn't eat much, and I was glued to my computer and my stuff and my models and everything else. And I know my colleague in Seattle she's busting her chops. So we're doing our part, but there is fundraising, grant writing, partnership with companies, manufacturing, so those are the pieces I have no control over.
Yeah, and those can be time consuming.
Highly so. And I'm very bad at those. I mean, I'm good at grant writing and I'm good at science, but I'm really lousy at business and politics and all the bits and pieces that go with the rest of the story.
Yeah, I participated in a conference with Bill Gates, and he kind of presented a timeline of creating a vaccine, it takes months and months at best. Like you said, if everything goes straight and everybody does their job, there are no blocks, it will take a minimum of 2 years, right, to have a real vaccine that is distributable.
You know, so the reason I designed this protein the way I did is because the like what Bill Gates was also talking about was setting up the manufacturing also to make the vaccines. And I know what they're doing in Europe is the vaccine platforms that are being tested are not interchangeable, so you have to build the manufacturing for each of those platforms, but you don't know which one is going to work. So you can build a manufacturing facility for something and it fails, but you have done it all together, so you're not wasting time. And I took that into my design because I didn't think that we should have to wait for building a new manufacturing facility. And those two companies that I mentioned, they already have everything that would be required to make this happen. So that was a consideration in the design of the vaccine for me, was that we wouldn't need a new manufacturing facility. So that shortens the timeline. And, you know, Gates is great, but I have issues with some of the things they've done too, some of the things Fauci's done, whatever. That's when you get into the politics of science, and then it becomes kind of weird.
Yeah, and you are more of the scientist, you know, the pure scientist. And you have given me so much to digest. And to digest, I have to study. And I
Okay.
wasn't expecting this, but this is wonderful, wonderful conversation. And to end this conversation at this point, I'm going to quote you. I love your molecule.
I love my molecule too. I love my molecule. I think it's got scope, and it's definitely getting us a response in mice, and I expect that that's going to carry through to the monkeys.
So you will keep us informed as the process goes, please.
I would be happy to do that. I would be happy to do that, you know, and yeah, I'd be happy to do that. I am going to chat with my colleague today, and we're going to discuss the patent application and filing. And I really hope she's made some progress with the funds for getting the protein made, because that's a stumbling block. We need to be moving the protein fast also. So everything that, you know, prevents us from moving fast is yet another delay. So we'll see. We'll see.
Arlene, thank you so much for
You're
your
welcome,
time.
Raul. It was a pleasure.
And we'll be in contact.
Okay then.
Good
Bye.
luck. Bye-bye.
Thank you.
Thank
Bye.
you.